Good morning everyone, this is your Do Now activity for today. So again, just like yesterday, I would like you to pause the video here and answer these questions in your class notebook assignment for today. Number 1 is state the flame test colour for sodium carbonate. Number 2, describe what you would see when silver nitrate solution is added to A, sodium chloride, B, sodium bromide, and C, sodium iodide. Number 3, state observations when acid is added to sodium carbonate. Number 4, name the 3 limiting factors of photosynthesis. And number 5, state why pasteurization is important in the production of yogurt and cheese. And then finally number 6, state 2 properties of polymers. So I want you to pause the video here, go answer these 6 questions, and then come back and we'll go through the answers. Okay, so these are the answers to the Do Now activity. Answer to number 1, sodium carbonate would give a golden yellow flame. Number 2, you would expect to see a white precipitate from sodium chloride, a cream precipitate from sodium bromide, and a yellow precipitate from sodium iodide. Number 3, when acid is added to sodium carbonate, we will see fizzing as carbon dioxide is produced. When the gas is bubbled into the lime water, it will turn cloudy or milky. So we see bubbles from the fizzing and milky lime water. Number 4, the 3 limiting factors of photosynthesis are temperature, light intensity, and carbon dioxide. The answer to number 5 is pasteurization kills bacteria to prevent food spoilage or food poisoning. And the answer to number 6, 2 properties of polymers. I've written more than 2 here, but as long as you have 2 of these, light, low melting point, and insulators. So give yourself a mark for each one you got right, and we'll move on to the rest of the lesson. Okay, so today's lesson, the title is chromatography. The date today is 10 Gwener 22 Ionawr. Your learning objective for today is to use chromatography to identify the components of coloured mixtures, and your keywords for today are retention factor, solubility, solvent front, and chromatogram. So chromatography can be used to separate mixtures of coloured compounds. Mixtures that are suitable for separation by chromatography include inks, dyes, and colouring agents in food. Simple chromatography is carried out on paper. A spot of the mixture is placed near the bottom of a piece of chromatography paper, and the paper is then placed upright in a suitable solvent. The solvent we usually use is water. As the solvent soaks up the paper, it carries the mixtures with it. Different components of the mixture will move at different rates, and this separates the mixture out. Okay, so chromatography is one of the specified practicals for your GCSEs, so we need to know all 5 steps of the method. So step 1, we draw a straight pencil line on a piece of filter paper 1 centimetre from the bottom. We have to use pencil for this line so that the pencil isn't taken up with the other ink dots when we put it into the water. Step 2, place a dot of different coloured inks on the line and label each dot. So the labels we use would be A, B and C for each dot. Step 3, fold the top of the paper over a rod or a wooden splint and secure in place with a paper clip. Step 4, dip the bottom of the filter paper into water. If too much of the paper is covered in the water, the ink will run into the beaker. Step 5, after the inks have spread, allow the paper to dry and measure the distance travelled by each ink. So pause this video now and go and watch the chromatography practical that Mrs. Saint has done for you. The link is below, and once you've watched that video, come back to here for the rest of this lesson. It's important that you see someone perform the practical, as it is one of your specified pracs. If the link on this slide doesn't work, it will also be in your class notebook assignment for today, or you can copy and paste the link into Google and it will work. So this is your task for review 1. I would like you to answer these questions in your class notebook assignment. So pause the video here to answer these 4 questions. The questions are: number 1, what can chromatography be used for? Number 2, what mixtures are suitable for chromatography? Number 3, what is simple chromatography carried out on? And number 4, what solvent do we usually use in chromatography? So pause the video here, answer these questions, and then carry on with the video to see the answers. So these are the answers to review 1. Number 1, we use chromatography to separate mixtures of coloured compounds. Number 2, inks, dyes and colouring agents in food are suitable for chromatography. Number 3, paper is what we use to carry out simple chromatography. And number 4, the solvent we usually use is water. So give yourself a mark out of 4 for these and we'll move on. Now this is what you've got for review 2. Again, you should answer these in your class notebook assignment. You have to fill in this table with the 5 steps for chromatography. So pause the video here and go fill in this table, and then we'll go through each step. This is what your table should look like for review 2. Step 1 was draw a straight pencil line 1 centimetre from the bottom of the paper. Step 2, place a dot of different coloured inks and label each dot. Step 3, fold the top of the paper over a rod and secure with a paper clip. Step 4, dip the bottom of the filter paper into the water. And step 5, after the inks have spread, allow the paper to dry and then measure the distance travelled by each ink. So give yourself a mark out of 5 for each step you got right. Okay, so we've looked at how we do chromatography, and now we have to look at analysing chromatograms. So a chromatogram is what you're left with once your paper has dried. So different chromatograms and the separated components of the mixtures can be identified by calculating the retention factor, or the RF value. The RF value of a particular compound is always the same if the chromatography has been carried out in the same way. This allows industry to use chromatography to identify compounds in mixtures. The equation we use to calculate the RF value is the distance moved by the compound divided by the distance moved by the solvent, which we also call the solvent front. So as you can see in this picture, the small green arrow shows the distance travelled by the substance, the yellow dot has moved from 0 to 3, and the distance travelled by the solvent is shown by the big green arrow, it's gone from 0 to 6. So we would divide these numbers to find out our RF value. Okay, so here are some examples of how we calculate the RF value. So I've got the equation at the top again. RF is the distance moved by the compound divided by the distance moved by the solvent, or the solvent front. So in example 1, we can see that navy moved a distance of 12 centimetres and the solvent front was 20 centimetres. So using our RF equation, we do 12 centimetres divided by 20 centimetres, which is 0.6. So our RF value is 0.6 for this navy ink. In example 2, violet moved a distance of 7 centimetres and the solvent front was 14 centimetres. So using our equation, we do 7 centimetres divided by 14 centimetres, which gives us 0.5. So the RF value for violet is 0.5. If we have an unknown substance whilst we're doing chromatography, we can use the substances we do know to work out what the unknown sample is made up of. So on this chromatograph we have X, A, B and C. So we don't know what X is made up of, but we do know the results we've got for A, B and C. So to analyse this chromatogram, to see what sample X is made up of, we draw horizontal lines from each dot in sample X. If the horizontal lines cross all the dots in sample A, B or C, then we know that sample X is made up of that sample. So if we do that now, we draw a horizontal line from each dot in sample X. Sample X has 2 dots, so we go horizontal line from there and a horizontal line from there. So we can see that all the dots in sample A are crossed with the line by here, and all the dots in sample B are crossed with a line, which is there. But the dot from sample C isn't crossed with a line, so we know that sample C is not part of sample X. But we do know that because the horizontal line crosses A and B, that sample X must be made up of A and B. Okay? So you've got quite a few examples of analysing chromatographs like this in your assignment for today. So if you could go and answer those now and then hand in your work for today. Thank you.